Hello everyone, my name's Andy Robertshaw. This is my first YouTube video. It's an introduction to the probabilities in the game of bridge. Hopefully it's the first of many videos that I do. Before I get going with this, what I would like to say is as this is an introduction to probability, it may appeal to some people who don't play bridge. If you're a maths student, maybe GCSE or A-level maths, it could appeal then. What I'll say before we get going is a quick explanation of how the cards are dealt in bridge. So a standard deck of 52 cards is dealt between 4 players. Each player has 13 cards. The 4 players sit round a square table. You sit opposite your partner and your opponents sit across, one left, one right. All 4 players have 13 cards. Okay. So the topics we will discuss in this, we've got introduction to the probability of a single event, the probability of an event not happening, or the complement of the probability. We've got mutually exclusive probabilities. So what that means is if 2 or more events cannot happen at the same time, they're said to be mutually exclusive. We've got independent probabilities. So I've got 2 separate events, and one of the events happening does not affect the probability of the other event happening. And lastly, we've got conditional probabilities. That means that the probability of one event has changed as a result of another event happening. So we can discuss the theory behind that. Okay, so let's start with the single events then. This should be fairly straightforward. So the probability of a single event is the number of positive outcomes divided by the number of possible outcomes, given that all outcomes are equally likely. So let me give you some examples of this. If we toss a coin, we are equally likely to get a heads or a tails. So we have 2 possible outcomes. The probability of getting a heads, that's one of the 2 outcomes, is 1 in 2. So 1 positive out of 2 possible outcomes. Probability of a heads is half, or 1 in 2. So that means if I toss a coin so many times, half the times I toss the coin I would expect to get a heads. Another example in probability, throwing a dice. So a dice has 6 sides. Each side has a number 1 to 6 written on it. I'm equally likely to throw any number. So my probability of throwing a 6 is 1 positive outcome out of 6 possible outcomes. So 1 in 6, or 1/6, is my probability. Let's get into the cards now. So the card I've used quite prominently in this presentation is the 8 of hearts. So I explained earlier how the cards are dealt. There are 4 players with an equal number of cards. That means each player is equally likely to hold the 8 of hearts. One of them certainly will. So the probability of holding the ace of hearts is 1 in 4, 1/4. Or another argument I could have used as the probability of holding the ace of hearts is, if I look at my own hand, I've got 13 of the 52 cards in my hand. So that's 13 possible outcomes. So the outcome of one of the cards in my hand, 13 of them, and the card could be in 52 different positions if we include all 4 players. So 13 in 52, or another way of arguing it is I have 13 out of 52 cards, so that is my probability. 13 positive outcomes out of 52 possible ones. 13 in 52 is 1/4, because 4 times 13 is 52. Right, so let's have a look now at the complement of a probability. So the complement is the probability of the event not happening. So an event will either happen or will not happen. Happening and not happening are mutually exclusive, which I will explain on the next slide. So I can add the probabilities together. So the probability of happening plus the probability of not happening is 1. Therefore I can rearrange this. The complement, the probability of the event not happening, is 1 minus the probability of the event happening. So the probability of not holding the ace of hearts is 1 minus the probability of holding it, 1 minus a quarter, which is 3/4. Or in other words, one of the other three players having the ace of hearts, 3/4, 3 possible outcomes, or 3 positive outcomes out of 4 possible if I'm asking the probability of somebody else holding it. Okay, so mutually exclusive. So 2 or more events can be mutually exclusive. That means that not more than one of them can occur. And we can add the probabilities together to obtain the probability of one of them occurring. So myself or my partner hold the ace of hearts. A quarter of the time I hold it, a quarter of the time my partner holds it. So the probability of one or other of us holding it, a quarter plus a quarter, which is a half. So what I guess I'm saying is there's no overlap. My partner and I cannot both hold the ace of hearts. Therefore, I can just add my own probability and my partner's probability together and not worry about any overlap between the two. The probability of one of the other 3 players holding the ace of hearts, this was discussed on the last slide, a quarter for my partner, a quarter for my left-hand opponent, a quarter for my right-hand opponent. I've got 3/4. So this is equivalent to saying I do not hold the ace of hearts myself with probability 1 minus probability I do have it. So 1 minus a quarter is 3/4. Okay, now independent probabilities, that means that one event happening has no bearing on the other event happening. So 2 or more events are independent if the probability of both or all can be obtained by multiplying the probabilities of each individual event. Okay, so the probability of holding the ace of hearts on the first hand is completely independent of that of the second hand. So I've got a quarter by a quarter, so quarter probability in the first hand of holding the ace of hearts, quarter probability in the second hand of holding the ace of hearts. I multiply them together, I get a 16th. So 1 time out of 16, when I play 2 bridge hands, I will hold the ace of hearts on both of them. Right, what I should say here is it's not independent on the same hand. So if I were to ask what's the probability of holding the king of hearts, given that I hold the ace of hearts on a given hand, then I've only got 12 cards left in my hand out of the other 51. So that's not independent, and we'll discuss that a little bit later. But certainly playing 2 separate hands of bridge offers independent probabilities. And I'll give you another example. I've got a dice and a coin. The probability of throwing a 6 and tossing a heads is a 6 times a half, which is a 12th. So that means if I throw a dice and toss a coin, I'll get a 6 and a heads 1 time out of 12. So conditional probabilities. This is what I was leading on to. So when I said the king of hearts in the hand is not independent from the ace of hearts in the hand, we'd need to consider the conditional probability for this. So B bar A is a way to do the probability of B happening when A happens. So A has happened, what's the probability of B given A? So if A is independent, then the probability of B happening when A happens, B given A, is equal to the probability of B happening irrespective of whether A has happened or not, because A happening does not affect the probability of B happening. So if they are not independent, the conditional probability is not equal to the standard probability of B happening, because the fact that A has happened changes the probability. So the probability of both B and A happening, we use this symbol. This is the intersection symbol, or the cap symbol, which means and. So it's the probability that A happens multiplied by the probability that B happens given that A has happened. And there'll be an example of this on the next slide. So let A be the event of holding the ace of hearts on the first hand played, and B be the probability of holding the ace of hearts on the second hand played. Or the event of, sorry, I should say. So the first hand has no bearing on the second. The cards are dealt quite independently. These are independent. So the probability of holding the ace of hearts on the second hand is a quarter. It's also a quarter given that you held the ace on the first hand. So this is lack of memory. Holding the ace of hearts on one round does not make you any more or any less likely to hold it on the second hand that you play. It's quite similar to me saying, if I throw a 6 with a dice, what am I likely to throw next time? What's my probability of throwing a 6 the second time? It's still 1 in 6. So a dice has a complete lack of memory property. So does a deal of bridge hands, so does a coin. If I toss a heads once, the probability of tossing a heads next time is still a half. If I've tossed a heads 10 times on the trot and it's a fair coin, the probability of tossing a heads for the 11th time is still a half. So, next example, I do mention holding the king of hearts. So, this is all in one hand. So holding the ace of hearts and the king of hearts on a given hand is not independent. So I've got a probability of a quarter of holding the ace. I've got a probability of a quarter of holding the king. But if you know that I've got the ace of hearts in my hand, does that change the probability of me holding the king of hearts as well? The short answer is yes, it does. So if I hold the ace of hearts, one of my 13 cards is the ace of hearts. I've only got 12 other cards out of the 51 of the cards. So I've got 12 out of 51. So therefore my probability of holding the king of hearts is 12 in 51, and I can cancel my fraction, divide by 3, 4 in 17. So the probability of holding the king of hearts, given I've got the ace, is 4 in 17. So the probability that I've got both the ace and king of hearts, I've got a quarter chance of holding the ace, and 4 in 17 of holding the king, given that I've got the ace. And I've got to multiply those together. Well, the 4's nicely cancel. I get 1 in 17, or roughly 6%. So 6% of the time, I'll have both the ace and king of hearts. If these were independent events, of course, I'd have a quarter times a quarter. I'd have a 16th there. So it makes a very small difference, really, but it does make a difference. And as you go further in, as you get more cards down the road, these cumulative differences count for a lot more. Okay, so what we've covered in this session then, an introduction to probability and single events, the probability of the event not happening, so the complement of the probability. We've done mutually exclusive probabilities, so that means if one event happens, then another cannot happen alongside it. So, for example, myself holding the ace of hearts and my partner also holding the ace of hearts, not both possible, so they're mutually exclusive. We discussed independent probabilities, so the first hand holding the ace of hearts not having any bearing on the second hand holding the ace of hearts. And finally, we discussed conditional probabilities, so when something is not mutually exclusive or independent, we can assess the probability of event A happening, the effect it has on event B. So, for example, what's the probability of holding the king of hearts? How does that change given you know I've got the ace of hearts? Okay, well, thank you for listening. I hope you enjoyed that. I'd love to continue with some more probability studies in the game of bridge, which should follow shortly. Take care.